2026 aspirants, so your midterm exams are ahead and we have already completed the one shot of the chapter D and F block elements. So now it's time to practice questions from this chapter. So in this video we are going to discuss all the 2+3 markers from this chapter that you can expect. Okay, so let's go ahead, and if I tell you what is the blueprint of this chapter, so you can expect two questions in the 1 marker section, and there will be one 2 marker question and 2 3 marker question. Okay, so in this if you remember, there is section B, okay, and then section C. In section B there will be one question. Okay, this one question from inorganic chemistry can either be from DNF block or from coordination, and here there will be 5 questions. It can be either 3+2 where 3 is from DNF block and 2 is from coordination, or it can be 2+3 where 2 questions are from DNF block and 3 questions are from coordination. Okay, so that is how it is distributed. So it can be anything. So here roughly we can expect 2 questions and 1 question in the 2 marker section. So let's now go for the 2 markers. So I'll be first discussing the sample question papers of 2025, then the actual question paper of 2025, then I'll give you the most expected questions. Okay, so coming to the sample question paper, this was something which was really unexpected question, out of the box question. So please pay focus on this question. The question is from SQP or model question paper 1. So it says iron catalyzes the reaction between iodide and persulfate ion in this reaction. Explain the catalytic action of catalyst iron 3 by using the chemical reactions. Okay, so now if I see, so what does it actually do? So this is the reaction. Fe+3 reacts with I- and gets converted to Fe2+ and I2. Now this I2 which is formed in this reaction reacts with this Fe2+ which is formed in this reaction reacts with S2O8 2- to give you Fe3+ and SO4 2-. Now if I add these two reactions, this is the final reaction I get. So exactly what is Fe3+? Fe3+ as a catalyst it is doing, it is reacting with I- giving you Fe2+. Now Fe2+ reacts with S2O8 and gives you SO4 2-. Okay, next we'll go to sample question paper 1 3 marker question. Study of actinoids is difficult. 3 reasons. This is a very I can say expected question, has been repeated many times. They are radioactive, very short half-life, and they could be prepared only in nanograms. Moving to the next question, this is also a very good question, again something which was expected question, but in a very different way it is asked. Okay, so a student of second PU, okay, second PU performs 2 trails of reactions between Ki and KMnO4. Okay, so this student does 2 reactions between Ki and KMnO4. In first trail, student adds small amount of acid to reaction mixture, and in second trail, student forget to add the acid to the reaction. The student observed that different color was obtained in the first and second trail. Give reason for the above observation and write the possible reactions. So I have told you that MnO4- reduces I- to I2 in acidic medium and IO3- in basic or neutral medium. So since in the second case there was no acid medium was added, so it is almost a neutral medium, and that is why we observe such reactions. Okay, so how can you write it? So in acidic medium what happens? Mn2+ colorless is formed and only iodine brown color is visible, whereas in neutral or alkaline medium brown MnO2 precipitate forms, giving a different color compared to the first case. That is the reason why there is 2 different colors. And what is the reactions for both of them? So in first case, that is in the acidic medium, you get Mn2+, and in the second case, that is neutral medium, you get MnO2, this one, right? Just a minute. Okay, here MnO2 and this one, sorry, this reaction is wrong. This gives you IO3-. Okay, IO3- is formed here, and here you have I2. Okay, moving to the next question. When a chromite ore A is fused with sodium carbonate in free or excess of air and the product is dissolved in water, a yellow solution of compound B is obtained. After treatment of this yellow solution with sulfuric acid C can be crystallized from the solution. When compound C is treated with KCl, compound D is formed. Write all the reactions. So if you know A, B, C, D, this is for the preparation of potassium dichromate. So you can see first of all iron chromate A reacts to give you sodium chromate. Then this sodium chromate reacts to give you sodium dichromate. Then sodium dichromate gets converted to potassium dichromate. Okay. Next we have from sample question paper 2. Now we will discuss. There was no 2-marker question, so there was directly 3-marker question. Fluorine has the abilities to stabilize the most of the transition metals in its higher oxidation state. Give 2 reasons with an example. So first of all, you can know first reason is higher lattice energy and next one is higher bond enthalpy. Examples COF3 and VF5 and CrF6. Already I have discussed these things. Next, what is lanthanide contraction, and name 2 elements that exhibits +7 state. So lanthanide contraction, we all know the steady decrease in the size of the atoms due to the poor shielding effect of your 4f orbitals, and then the +7 oxidation state is shown by, you have to say actinoids, that is NP and PU. Next we have name the important alloy which contains the maximum percentage of lanthanoids and its use. So mic metal, and it is used in the bullets, shell and lighter flint. Okay. Next we have sample question paper 3. Write the equations for the preparation of potassium permanganate. So we know the preparation of potassium permanganate, MnO2 KOH will give you K2MnO4. Then again this one gets converted to MnO4 minus, right? And what is the color of KMnO4 crystals? It is purple in color. Next we have transition elements have higher enthalpy of atomization. Give 2 reasons, and then among 3D and 4D which one will have higher enthalpy of atomization. So 2 reasons will give you 2 marks, and answering this part will give you 1 mark, so total 3 marks. So first of all, they have higher enthalpy of atomization because of unpaired electrons and strong metallic bonding. Now out of 3D and 4D, so here first of all write 4D has more enthalpy of atomization. Okay, has more enthalpy of atomization. Okay, now this is due to the strong metal-metal bonding in heavy transition metals 4D and 5D than 3D series. Okay, that is due to the strong metal-metal bonding in heavy transition metals. Now we will go to PYQ 2025, the actual question paper that was asked in 2025. 2 characteristics of interstitial compounds. Here I have given you 4 characteristics. You can write any 2. First of all, they have high melting points, they are chemically inert, they retain the metallic conductivity. So 3 points I have given you. You can write any 2 here. Next, write the balanced equation in the manufacture of potassium dichromate from chromite ore, the same which we have already discussed. Iron chromate to sodium chromate, sodium chromate to sodium dichromate, sodium dichromate to potassium dichromate. Now we'll go to next one. What is lanthanide contraction? Write 1 comparison and 1 difference between the lanthanoids and actinoids with respect to the oxidation states shown by them. So here first of all, what is lanthanide contraction? I have already discussed you. The filling of 4f orbitals before 5d orbitals result in a regular decrease in the atomic radii called as lanthanide contraction, which essentially compensates for the expected increase in the atomic size with atomic number. Okay. Now what is the similarity between them? So both lanthanoids and actinoids have a common oxidation state of +3, and what is the difference? Lanthanoids mostly exhibit limited oxidation state +2, +3 and +4, whereas actinoids have more variety +3 to almost from +7 because of the closer energy levels of 5D, 5F, 6D and 7s orbitals. Next we have 2-marker questions which I expect you should prepare. Most expected questions: maximum melting point and minimum melting point in 3D series. So chromium has maximum, zinc has minimum. Next we have 2 examples of amphoteric oxides. This is very important: V2O5 and CrO3. Next, tungsten metal is used as a filament, but zinc metal cannot be used. So we know that tungsten is an element of 5D series. Okay, it has unpaired electrons. It has strong metallic bonding. So its melting point is very high. Okay, so that is why we can use that for the filament of boiling point, filament of bulb. But zinc is not having lone pair. Is not having unpaired electrons, so it does not have metallic bonding also, so that is why its melting point is very low. So when you make filament of zinc, it will immediately melt and it will vaporize. Okay, so you can see here Tungsten is used in light bulb filaments due to its high melting point, that is 3422 degrees Celsius, which prevent it from melting at the intense temperature required to produce light. In contrast, zinc has a very low melting point of only 419 degrees Celsius, which would quickly vaporize, making it unsuitable for light bulb filament. Okay. Next, we have give reasons. Question number 4, Cu plus 2 is more stable than Cu plus, and ionization enthalpy increases along the transition elements from left to right. So Cu2 plus is more stable because of, so why this question is more important? Because Cu plus has an electronic configuration of D10, whereas Cu2 plus has an electronic configuration of D9, right? Now technically this is D10 configuration, exactly half filled configuration, so this should be more stable, right? But that does not happen. Instead, we find D9 in aqueous medium is more stable. So the reason for here is very simple, that is when you have Cu2 plus, it has less size and it releases more hydration energy, that is why it is more stable. Next, ionization enthalpy increases along the transition elements from left to right. So along as we move left to right, the effective nuclear charge increases, and that is why the ionization energy also increases. So first of all, Cu2 plus has higher hydration enthalpy than Cu plus, which compensates to the higher ionization energy required for the Cu2 plus, hence Cu2 plus is more stable and due to the increase in effective nuclear charge. Moving to the fifth question, why do transition elements have higher enthalpy of atomization? The first thing is they have large number of unpaired electrons, and these unpaired electrons are involved in stronger interatomic interactions and stronger bonding between the atoms. Next, we have why is Cr2 plus reducing and Mn plus 3 oxidizing when both have D4 configuration. So first I will explain this one, please understand, then you can write it in your own words. Okay. So let us see Cr2 plus and I have Mn3 plus. The question is saying that Cr2 plus is also having D4 configuration, Mn3 plus is having also D4 configuration. Okay. Now Cr2 plus is reducing in nature, means it reduces others. Then what it will undergo? If it is reducing others, itself it will undergo oxidation. So Cr2 plus will undergo Cr3 plus and its configuration is D3. Now Mn plus 3 is oxidizing in nature. It will oxidize others, itself it will get reduced. So Mn plus 3 will get converted to Mn plus 2, which is D5 configuration. Now I told you so Cr2 plus from an unstable state goes to a stable state, so that is why D4 gets converted to D3 and it undergoes, in that process it is undergoing oxidation, so it is behaving as a reducing agent. Whereas Mn plus 3 is getting converted to Mn plus 2 from again unstable to stable, right? This is becoming more stable. So now here what I can observe here, Mn plus 3 to Mn plus 2, there is reduction, so it behaves as an oxidizing agent. Okay. Now we can see the answer. So Cr2 plus, so you have to explain it properly. See, Cr plus 2 D4, electronic configuration is this one. It readily gets oxidized to Cr3 plus D3, which has a stable half-filled T2G3 configuration. So that is why Cr2 plus can act as an reducing agent. Compared to Mn3 plus has a D4 configuration, it readily gets reduced to Mn2 plus because it gets a D5 configuration, which is more stable due to half-filled nature. So that is why Mn plus 3 acts as an oxidizing agent. So what we can conclude here, even though both Cr2 plus and Mn3 plus are D4 configuration, Cr2 plus prefers to lose one electron. It prefers to lose one electron. So that is why it is a reducing agent, and Mn plus 3 prefers to gain an electron. So that is why it is an oxidizing agent, because they move towards their more stable electronic configuration. Okay. So Cr2 plus loses one electron and moves towards the more stable configuration, whereas Mn plus 3 gains one electron and moves towards the more stable configuration. Okay. Next, which is a stronger reducing agent, Cr2 plus or Fe2 plus, and why? Again, let me explain you this answer first. See, stronger reducing agent, you have Cr2 plus and Fe2 plus. Okay, reducing agent means what? It will reduce others, itself it will get oxidized. So Cr2 plus will get converted to Cr3 plus and Fe2 plus will get converted to Fe3 plus. Cr2 plus, Cr configuration is what? 3d5 4s1. So Cr2 plus has 3d4 configuration and Cr3 plus has 3d3 configuration. Now Fe2 plus has d6 configuration and Fe3 plus will have d5 configuration, right? Because Fe configuration is 3d6 4s2. Okay, so that is there. We have understood this one. So now what will happen? Now if you see that both are undergoing what I'll say oxidation, both are undergoing oxidation, so both are reducing agent. But out of this, which is a better reducing agent? So we have to talk whether D3 is more stable or D5 is more stable. So actually D3 is actually T2G3 configuration. Okay, so this is more stable than this one, so that is why this reaction happens more easily, or this one is a stronger reducing agent. Cr2 plus is a stronger reducing agent. Now how do we write this exam in the exam? So first of all you can explain each of them and then you can give a conclusion. So Cr2 plus tends to get oxidized to Cr3 plus, so D3 configuration. Cr3 plus has a stable T2G3 half filled configuration. Therefore Cr2 plus is eager to lose one electron, it is a stronger reducing agent. Talking about Fe2 plus, it gets oxidized to Fe3. Now Fe3 plus has a stable half filled configuration, but the process here is less favorable compared to Cr2 plus to Cr3 plus because Cr3 plus is more stable than Fe3 plus. Okay, so Cr2 plus is a stronger reducing agent than Fe2 plus because Cr3 plus is especially stable in the half filled T2G3 configuration. Okay, just you have to explain it properly and then you have to write down. Moving to the 8th question, calculate the magnetic moment. So what is the electronic configuration of titanium? 3d2 4s2. Okay, next Ti3 plus will have 3d1, right? Ti3 plus will have 3d1 configuration. Now how to calculate the magnetic moment? Root over of n into n plus 2. Okay, now n value here is 1. Okay, now if I substitute here root over of 1 into 1 plus 2, that is equal to root over of 3, which is equal to 1.73 bm. Okay, next one, 9th question, transition elements form colored compounds give 2 reasons. So first of all they have unpaired electrons and these unpaired electrons can undergo DD transitions, and when they emit light, they emit light in the visible region, so that is why they are colored compounds. So how do we write them? The color of the transition metal is due to the presence of unpaired electrons in the d orbitals which undergo DD transition. The unpaired d electrons absorb color from the visible region and undergo DD transition and radiate the complementary color again in the visible region. Okay, that is why it is colored compounds, or we visualize them as colored compounds. Next we have draw the structure of dichromate ion and what is the angle. So this is the structure of dichromate ion, or you can just draw it like this also. Cr, you can show one with double bond and you have like this. Right, so these will be under what I'll say continuous resonance, and these will be under continuous resonance, but there is no change in this bond, so this bond angle is constant, which is 126 degree. Okay, now we will move to some 3-marker questions. Okay, so first question is how do K2Cr2O7 reacts with I minus, Fe2 plus, Sn2 plus and H2S. Okay, so first let us talk about the reaction of Cr2O7. How does it react first? So see, Cr2O7 2 minus, it gets converted to, okay, plus 6 to plus 3. There is reduction. So how many electrons are gained here, so plus 6 to plus 3, 3 electrons are gained. Now 2 chromium are there, so total 6 electrons will be gained. So I can write here 6 electrons. Okay. Next, what you see, 7 oxygen is there, so you have 7 oxygen. Okay, and then you have this one as 14H plus. How to balance it? This extra, so to balance oxygen you should add water, and when I added this water, this hydrogen is produced, that can be written here. Okay, so this is the final equation for chromium. Now let's talk about I minus. How will I minus react here? I minus reduces to I2 by loss of 2 electrons. Okay, now the number of electrons, if I want to make it same, I have to multiply with 3. So that will give me 6I minus gives 3I2 plus 6 electrons. Okay, now this is the reaction. I have to make the number of electrons same, right? So that is why I multiplied 3. Now these are the two equations, and now you can just add them to get the final equation. So my final equation will be Cr2O7 minus, okay, plus 6I minus, okay, then this 6 electron gets cancelled, so I have 14H plus, then I have 1, 2, 3, this side I have 2 Cr3 plus 3I2 plus 7 water. Okay, so this is the reaction that I will get in case of I minus. Next, if you want to do for Fe2 plus, so what will happen? Fe2 plus will get converted to Fe3 plus with 1 electron. Now you want to make it 6 electrons because here it is 6, so you have to multiply with 6 and then you have to add with this equation. So similarly you have to do, I have explained you, so I will show you the final equation. You can see here I have for all of them. So this is for I minus, then you have for Fe, then you have for S2 minus also, and then for Sn2 plus also. So all the electrons you have to do in the similar way, and then you can check here. Okay. Next question we have again on the based of reaction. So write the reaction balanced one for potassium permanganate and iodide ion in acidic medium. So this is again important. So how will you first balance potassium manganate? MnO4 minus. In acidic medium, we know that it gets converted to Mn2 plus, right? So plus 7 to plus 2, we have 5 electrons. Now there will be 4 oxygen, so I need 4 water molecules, and since there is 8 hydrogen, so I'll get 8H plus. Okay. Now we have I minus. Okay, I minus gets I2. Okay, 2I minus loses 2 electrons. Now to balance this one, what I'll do, I'll multiply this with 2 and this one with 5. Okay, so I have here 16H plus 2 MnO4 minus, okay, plus 10 electrons, that will give me 2 Mn2 plus 8 water molecules. And here I will have 10 I minus gives me 5 I2 plus 10 electrons. Okay, so this 10 electron will get cancelled. Now if I add these two, what will the final equation I will have? The final equation, I think you can see here, I'll have 16H plus 2 MnO4 minus plus 10 I minus. This is done, this is done, this is done. This side I have 2 Mn2 plus 5 I2 plus 8 water. Okay, so now if I solve this this reaction, you can just see, I'll erase this one. Here you have the final equation 16H plus 2 MnO4 minus plus 10 I minus gives 2 Mn2 plus 8 water plus 5 I2. Okay, then you have reaction between potassium permanganate and iodide in neutral medium. So in neutral medium, what I'll get? IO3 minus. Accordingly you have to balance, and then oxalate ion C2O4 minus will get converted to CO2. Finally it will get converted to CO2. Next question, reaction of lanthanides with the following. So with carbon you will get LnC2, with nitrogen LnN, and with acids it will produce hydrogen gas. Okay. Next, we have give reasons for the following. Actinoids show higher oxidation states. So the actinoids have more number of variable oxidation state. What is the reason for that? The first of all, in actinoids 5F, 6D and 7S, all of them have comparable energies. So they all can participate in bond formation. So that is why they show higher oxidation states. Next, actinoid contraction is greater from element to element than lanthanide contraction. So the first of all, in actinoids 5F electrons shield the nuclear charge very poorly compared to 4F electrons. Okay, 5F have more shielding effect. 5F have poorer shielding effect. Okay, so that is why the effective nuclear charge increases, pulling the electrons closer. Next, we have chemical properties of actinoids is less known. This I have already discussed. They are highly reactive with short half-lives, and they are available only in minute quantities and can in nature or prepared artificially. They are present only in nanograms. Okay. Next question, E naught of M2 plus to M value for copper is positive. What is the reason for that? So the reason is they have a very high atomization and very low hydration enthalpy. Next, scandium has less value for E naught of +3 to +2, because we know that I have explained this in one short video. Scandium +3 has a stable configuration, right? It is a stable noble gas configuration, so it doesn't want to go to M2 plus state. It is happy in +3 state, so that is why it is having less value. Next, zinc has a higher value of M +3 to M +2. Again, Zn +3 is D9 configuration, this is D10 configuration. So we are going from an unstable to stable species, right? So if we are going from unstable to stable, the reduction will take place easily, and that is why the value is very high here. Next question, difference between lanthanoids and actinoids. You can just see this, I will discuss. So first of all, electrons enters to the 4F orbitals. Here electrons enters to the 5F orbitals. They are non-radioactive except promethium. Here all the elements are radioactive. Next, binding energies of 4F electrons are higher because they are closer to the nucleus. Binding energies of 5F electrons are lesser. They are basic, they are less basic, more basic. Maximum oxidation state is +4, maximum oxidation state is +7. 4F have greater shielding effect, 5F have poor shielding effect, means both of them have poorer, but if I compare, 5F is having less shielding effect than 4F. Next, lanthanide contraction is lesser, here actinide contraction is greater. Okay, so I think those are the most important questions from this chapter, so please prepare them and please watch my one shot video on this chapter. It is going to be one shot revision, very important. I have discussed everything in brief. There also you can find many questions, so please prepare that and watch this video. That will help you to complete this chapter. Thank you so much, and if you have any doubt, please put down in the comment section. I'll definitely address it, and all the best.